excuse me, the acylation. An acyl group is basically a carbonyl group. That's another word for an acyl group. Okay, so we're going to be making ketones. You make a ketone from this. And what you use is an acid chloride. We've learned an acid chloride functional group. That's an acid chloride. Same catalyst, aluminum trichloride, and you attach the carbonyl to the aromatic ring. So it's a ketone, but notice it's a special kind of ketone. It's a ketone that has an aromatic ring. Okay, so again, let's do a real reaction just to give you an example. AlCl3, so, and you form the methyl ketone. All right, so that is the Freeland-Crafts alkylation and acylation. All right, 5.6 now. So we've learned, let's see, 1, 2, 3, 4, 5 new reactions. Okay, the reactions we've learned are making mono-substituted compounds. So you take a benzene ring and put on a nitro group, or a benzene ring and put on an acyl group, or a benzene ring and put on a bromine group. Well, what happens if you already have a group on your ring and you want to put on a second group? And it's what's called a substitution effect. Okay, this is kind of neat. So here's what the reaction is. You have a group currently on your ring, and you want to do a reaction, and you want to put Y on your ring. Well, there's technically 3 possible products that you can form. Right? You can form the ortho, you can form the meta, or you can form the para. The question is, do you get a statistical mixture? So do you get 33% of one, 33% of another, and 33% of another? That's the question. Or do one of these isomers favor, is one favored more than the other? Well, I wouldn't be making a big deal out of this if one of them was not favored. All right. If you got a statistical mixture, I would just say you get a statistical mixture and that's it. Obviously, you don't. You actually favor one of these structures over the other, all depending on what X is. Okay. So your X group can either be an ortho-para director, or X can be a meta director. All right, and what that means is that the group originally on the ring, so whatever X is,